about to jump into section 4.1 where we're going to study right triangles. And one of the things we're going to have to do is identify the length of all three sides of the right triangle before proceeding. And sometimes you are only given two sides of the triangle and you have to calculate the third side of the triangle, and to do that you use the Pythagorean theorem. And what ends up happening a lot of the time is that one or more of the sides of the triangle involves a square root. Okay, so one of the things, when your answer may involve a square root because of that. And so when you're stating your answers are always going to be exact, unless you're asked for a decimal specifically. So if you're giving an exact answer and your answer has a square root in it, your square root is going to have to be simplified. Okay, so the first thing we're going to talk about, because you're going to see a lot of square roots, not only in section 4.1, but just throughout the course. And like I said, your square roots always have to be simplified. So I want to make sure that you know how to simplify a square root. Okay. On the first page here, there are some steps written down for simplifying a square root. Okay. So you can read through those. I'm not going to read through these. I'm actually just going to jump in and start doing a couple of examples so you can see how this works. You've probably done this before. It just may have been a while since you've done this. Okay. But again, if you need to refer back to the steps on how to do this, just come back up and read this. Okay, so let's just jump into example R1, review material. So example review number 1. I give you a couple of square roots and I want you to simplify the square root, and it says give an exact answer, no decimals. Okay, so we're going to start off with the square root of 50. Okay, so there is a way to quote unquote simplify this. It may not look simplified, but in the world of mathematics, it's considered simplified. Okay, this is what we're going to do here. Okay, if you take the number underneath 50, okay, you're going to build something called a factor tree. Okay, so like I said, this is something you've probably done before. Okay, so take the number underneath 50 and you start breaking it down. Okay, so think to yourself, what do I multiply together to get 50? Okay, there's a couple of pairs of numbers that work. Okay, 2 times 25 is 50. 10 times 5 is 50. Okay, there's, like I said, more than one pair. It doesn't matter which one you pick. Okay, just pick something and go with it. Okay, I'm going to go with 2 and 25. But if you had picked 10 and 5, at the end of the day, it's going to come out the same. All right, so you can see I use the phrase factor tree. Okay, it's kind of branching out like a tree. Okay, so now we're going to go to each number and see if we can break it down even more. Okay, 2 is not going to break down anymore. It's just, to get 2, it's going to be 2 times 1. So you really can't break it down anymore. But you can break down 25 into 5 times 5. Okay, so then you ask yourselves, you want to keep going until you can, no longer break anything down. Okay, both of these numbers are 5s. Okay, we can't break them down any further because 5 only breaks down into 5 times 1. Okay, so what we're going to do is we're going to circle the numbers at the ends of the branches. Okay, and if you multiply these numbers together that you've circled, you should get 50. 2 times 5 is 10 times 5 is 50. Okay, all right, so that means we're ready to start simplifying our square root. Okay, I am trying to simplify the square root of 50, so I'm going to bring the square root back. Okay, in the next step, I am going to rewrite 50 using these numbers that I've circled. Okay, and I'm going to write it in a specific way just to make sure it's easier to read. These numbers that I've circled, I'm going to write them in ascending order, and I'm also going to put pairs by each other. Okay, so this is going to be 2 times 5 times 5. It just so happens I already have it written that way in the tree. Okay, when you look at this statement, it's the same thing on both sides. Okay, both sides have a square root. 50 is underneath the square root on the left and also on the right, because 2 times 5 is 10 times 5 is 50. Okay, so now you get to simplify the square root. Okay, so what you do is you look underneath the square root and you look for any pairs of numbers that you have, okay? Well, I see a pair of 5s, okay? So what happens here is I circle my pair, and then I take one of the 5s out. One of the 5s comes out, not both, okay? And since I use them, okay, I'm going to go ahead and cross them off because I no longer need them, okay? The reason this is working is because 5 times 5 is 25, and that quantity is under a square root. The square root of 25 is 5, so that's why 1 comes out. Okay, so all you have to do is find your pairs, circle them, cross them out, and for each pair, one of them comes out, not both. Okay, 2 was not paired up with any other number. Okay, so it's just going to stay under the square root. Okay, so we're done. That's it. Okay, so what this is saying is that to simplify, it may not look simplified, but like I said, mathematically it's considered simplified. The square root of 50 is the same thing as 5 times the square root of 2. Okay, that's considered simplified. Okay, now I know that the directions said no decimals, okay, but I'm actually going to put these into the calculator just so you can see that if you have the square root of 50, it's the same decimal approximation as 5 times the square root of 2, okay? They're the same number, even though they are written differently. So let me pull up the calculator. All right, so I'm going to go to the calculator, and I am going to type in the square root of 50. Okay, that's what we started with, okay? So the decimal approximation is about 7.07, okay? But then we used our factor tree and we simplified the square root to be 5 times the square root of 2, okay? So boom, you get the same decimal approximation, okay? So these square root of 50 or 5 times the square root of 2, they are the same number, okay? 5 times the square root of 2 is just considered the simplified version of the square root of 50, okay? All right, so that is what it means to simplify a square root, okay? Let's try another one. Okay, so in part B, we're going to try to do the square root of 72. Okay, we're going to do it the same exact way. Okay, we are going to start by building a factor tree for 72. Okay, so the first pair of numbers that pop into my mind are 8 and 9. Okay, so 8 times 9 gives me 72. Okay, I'm going to work with the 8 and start breaking that down. 8 breaks down into 2 times 4. Okay, and then the 2 doesn't break down any further, but the 4 breaks down into 2 times 2, and then the 9 breaks down into 3 times 3. Okay, and the 2's don't break down anymore, and the 3's don't break down anymore, and so we're done. Okay, we're going to go to the bottom of each branch and circle the numbers at the bottom of each branch. Okay, all right, so now we can start rewriting the square root. Okay, we have been working with the square root of 72. Okay, we're going to use these numbers from the factor tree to rewrite the square root of 72. Okay, so you're going to keep your square root sign. Okay, we're going to reorganize these numbers. Okay, we want to put them in ascending order and put pairs by pairs. So we're going to have 2 times 2 times 2 times 3 times 3. Every time I keep making these factor trees, they keep coming out in the correct order. Okay, it's not a requirement to organize your numbers this way. It's just easier to read. Okay, all right, so we can check ourselves. 2 times 2 is 4, times 2 is 8, times 3 is 24, times 3 is 72. Okay, so both sides are the same, the square root of 72. Okay, all right, next step, look for pairs. Okay, I see a pair of 2's. Okay, I have 2 2's, so I'm going to circle them and cross it out, and one of the 2's comes out. Okay, so underneath the square root, okay, I've crossed out this pair of 2's. That's going to leave me with 2 times 3 times 3 underneath the square root. Okay, when this 2 comes out, it is multiplied by the square root. Okay, now if you look under the square root, you still have a pair of 3's. Okay, so now you're going to have to take this pair of 3's, cross them out, one of them comes out. Okay, so the 2, remember this red 2, it's already hanging out front. Okay, and then one of the threes comes out, okay, and we're multiplying by the square root, okay, the 2 is still by itself. It's all by its lonesome. It stays underneath the square root, okay. So this is what we end up with. Okay, so what you can do, you can simplify this a little bit more. Okay, one of the 2's came out, one of the 3's came out. Those numbers are going to be multiplied together. So this is going to be 6 times the square root of 2. Okay, so that is the simplified version. Okay, so the square root of 72 is the same thing as 6 times the square root of 2. Okay, again, you could go to the calculator and check this. Okay, it should be the same decimal approximation. There's the square root of 72, and then the simplified version is 6 square root of 2, same decimal approximation. Okay, so you know that you're right. Okay, so again, in this class, okay, you will see lots of square roots. Okay, and anytime you encounter one, you need to make sure that your square root is simplified.